It's 2 o'clock. It's time for our joint webinar. Let's give the people some more minutes to join so we set up our presentations. So it's 1 minute after 2. We have a busy schedule, so we would really like to start with the FinTech and InsuranceTech case studies, digitally transforming Europe's future with big data and artificial intelligence-driven innovation. I'm Marieke Willems, I'm project manager at Trust IT, and I'm involved in the BigDataStack project. We have joint efforts with Infinitech and the Big Data Value Task Force on big data and artificial intelligence for finance and insurance. So welcome everybody. We're very happy that you've been able to join today. Just want to give you a quick overview of why this webinar, why did you join? So we went from Porto for the BDVA Summit 2020 to a virtual summit. So that's why we're having this webinar and that's why we're very happy that you've all been able to join. Another reason is the new data-driven industrial revolution highlights the need for big data technologies to unlock the potential in various application domains. So this is one of the examples that we will be giving. Infinitech, BigDataStack, and the BDVA Task Force on Big Data and Artificial Intelligence for Finance will showcase how the data-driven innovation contributes to Europe's digital future in insurance and finance. So we will do this on the basis of 3 Infinitech case studies that will be setting the big data analytics requirements. Then after that, we will be showcasing 3 big data stack technologies that are fit to answer the big data analytics requirements. And of course, this is a wonderful opportunity to engage with our lineup of big data experts and artificial intelligence experts. So this is the agenda of today. You've seen it announced widely. I'll go over it quickly because we have a very full program that we really want to share with you. These are today's speakers. So it's Vittorio Monferrino from GFT, active in Infinitech, Kranos Pavlos from LeanXscale, both involved in Infinitech and BigDataStack, Marco Rotoloni from AB Lab, on the BDVA task force for big data and artificial intelligence in the finance and insurance. It's Demosthenes Kyriazis from University of Piraeus, involved in BigDataStack and Infinitech. Jose Gatos from Atos, involved in Infinitech. Youssef Moati from IBM Haifa Research, project coordinator from BigDataStack, and Richard McCready from the Glasgow University, involved in BigDataStack and Infinitech as well. So we would really like to ask you to engage with today's lineup of experts through the online opportunity to ask them questions. So we will go as the agenda indicates. We ask you to not forget your question, just prompt it in the platform. We will then at the end of the webinar open the floor to all the questions. You will then be able to read them out, tell us the questions you have at that point, or we will simply read out your question and drive them to the respective experts that we have today. So now we have a few questions to you. We would like to know who we have on the call. We would like to know who you are to understand a little bit better what your needs are and what your questions are. So here you see a poll. Please answer the poll as the questions pop up. So this is your chance now. So to which of our stakeholder types do you belong? So please provide your input there. Please tell us who you are. So are you a big data provider? Are you working in the finance and insurance sector? Are you a big data technology provider? Are you a policymaker, standardization body? Then the question 2 is already up here. Are you working in or with the finance and insurance service industry? Okay, I see a lot of answers are coming in. Thank you. So a lot of research in academia, big data technology providers. We have big data providers as well. There are people from the finance and insurance sector. We have policymakers on the call. Okay. Andrea, could I ask you to proceed to the next question?
Yes, Mike. Honestly, all the questions have been updated there on the panel.
Okay. So I have to
People
scroll
are
down.
all at once. Yeah.
Oh, perfect. Perfect. So we're 50-50 people working in the finance insurance service sector. Are you working with big data? A lot of us are on the call. Are you interested in big data technologies to optimize your customer experience? Most of you are, and some of you are trying to find that out. We hope we can help you with that during this webinar. And what is the main barrier of risk preventing you from implementing big data analytical solutions in your organization? So there's costs, lack of expertise, and uncertain value. Okay. Perfect. Let's give it 10 more seconds for answers to come in, and then we move on to Vittorio. Okay, thank you. So I stopped sharing, Vittorio, it's your turn.
Okay, well, good morning to everyone. I'm Vittorio Monferrino. Let me share my screen. Okay, can you see it? Yeah, okay. Good morning to everyone. I'm Vittorio Monferrino from GFT, and I'm going to talk to you about the Infinitech project. Infinitech is a flagship project in the digital finance sector, and it is one of a kind. Why is that? Because the financial sector is a very hard and difficult one, and it is historically conservative. So it is resistant to digital transformation, and because of several reasons. The most important are the long time that is needed to implement the solutions in the financial services, the complexity of the systems that are very difficult to be changed, and the vast amount of regulations that all the financial and insurance services have. However, the world is changing, and the digital technologies are transforming the world and the businesses, and the financial services are trying to follow this path. One of the biggest problems that they face is related to data. Indeed, the majority of the applications are data intensive, and they leverage technologies on fragmented data sources. Indeed, it is very hard and difficult to process and extract information on data that are on different data sources and different databases. So Infinitech has been created in order to solve these issues. Before detailing it, I'm going to give you some facts and figures. So Infinitech is an H2020 project co-funded by the European Commission as Innovation Action. Its project budget is around 21 million and the grant of almost 60 million of euros. And it has a very huge consortium, so almost 50 participants. The Infinitech is based on 3 different pillars: the innovation, the execution, and the market. And why is that? Infinitech is innovative because it leverages on novel technologies, starting from big data, IoT, AI, machine learning, and so on and so forth. And they extract information from fragmented data sources. Another reason is its reference architecture, its flexible approach that has been created in order to have a reference model to map and represent the 15 different pilots that are within the project. The execution, because it integrates the banking and the finance systems, and because it follows the novel approach of testbeds and sandboxes in order to develop and deploy the different pilots. And then the third pillar is market, because InfinTech is market-oriented. Indeed, all the use cases are industry-driven, and they are applied in a lot of different fields, and because of its business model, its marketplace, and its virtualized digital innovation hub. The other important part of InfinTech is its team, its consortium. So we have universities and research centers to represent the innovation and to bring the innovation in the project. We have, let's say, the big guys, the digital finance vendor and the system integrators, such as GFT, IBM, SIA, Fujitsu, and so on and so forth, in order to execute the results. And we have then the market side, as you see, is central, because there are the fintechs, the high tech, the small medium enterprises, and the financial institutions, including also big banks such as Bankia or aggregators such as Abielab. So InfinTech is innovative, again, because it brings together the global leader in ICT and finance that provide a globally unique pool of data assets, huge amount of big data and databases. And through the project, we extract and analyze information from these data assets, utilizing different technologies, such as I said, artificial intelligence, machine learning, predictive or prescriptive analytics, blockchain, and so on and so forth. Everything while being fully compliant, utilizing a regulatory toolbox in order to be compliant with the regulations, such as GDPR, PSD2, anti-money laundering. All these components are brought together in the use cases in order to be developed and deployed in testbeds and sandboxes. We define testbeds as the infrastructure on which the pilots will be deployed, and the sandboxes are the all components and the applications that configure and form the different use cases. Another important part of the innovative side of InfinTech is its mapping with the Europe's digital future. It starts with an open and democratic sustainable society, which deals with control and protection over data, anonymization and encryption techniques, synthetic data, ethic and legal compliance, a whole coverage of the regulations. It then goes with technologies that work for the people, while being fully safe and secure. For example, we tackle arguments such as fraud detection, anti-money laundering, and terrorism. And all the algorithms respect the user's privacy. And we provide us access to trainings and services to the users. Lastly, a fair and competitive digital economy. On one side, there is the hyperconnectivity, the IoT, and all the use cases that brings together the different components. We have the marketplace and the virtualized digital innovation hub, and we have a shared testbed in order to facilitate the small and medium enterprises and deploy their pilots in a testbed and infrastructure provided by the project. We have, as I said, 15 pilots in the project, divided in 5 different clusters. The 3 initial clusters are more related to the financial sector. They start with personalized retail and investment banking services with, for example, know your customer and other use cases related to the interaction between the clients and the banks. We have then the smart and reliable and accurate risk assessment that deals with credit risk scoring, sustainability index scoring, and so on and so forth, and the predictive financial crime and fraud detection. The last 2 clusters are related to the insurance sector, and my colleague Jose will explain you better some of the pilots afterwards. The first one is more related to IoT connected vehicles, so personalized user-based insurance pilots such as pay as you drive, and the last cluster is related to agricultural sector and the insurance in connection with this agricultural sector. So as you can see, in InfinTech, there are a lot of pilots and they all cover different fields and sectors. Lastly, there is the marketplace that brings together all the components of Infinitech in order to show them to the outside world, and the VDIH, the Virtualized Digital Innovation Hub, that brings together the expertise and the services of the consortium in order to provide services and consultant to help businesses in achieve their digital transformation. Lastly, we have the so-called Infinitech Stakeholder Alliance, that is a communication channel between the consortium and the outside stakeholder in order to exchange knowledge and information and give them the possibility to provide feedbacks and evaluations in all the activities that we are carrying on. The last point is related to the execution. And in Infinitech, we are going to execute and deploy all the pilots in different testbeds, as I said, the infrastructure and sandboxes. The sandboxes are the applications and the merge of the components of the pilots. And all the banks will deploy their own pilots on their infrastructure. The small medium enterprise and the FinTech companies will deploy their pilots in a shared testbed provided by the University of Nova. And after my speech that is almost done, Pavlos, my colleague, will talk to you about the reference architecture of Infinitech and the building blocks. Sorry for stealing some time, and I'm done. Thank you for the attention.
Thanks, Vittorio. If you have any questions for Vittorio, please put them in the questions and answer mode that we have at the bottom of the webinar platform. Then I would like to give the floor to Pavlos Kranas from Linux Scale. Pavlos, the floor is yours.
Thank you, Mariek. I guess you can see my screen now. So, hello, my name is Pavlos Kranas. I'm working for Linux Scale, which has the responsibility of the overall technical coordination of the Infinitech project. I will try to provide you a quick technical overview of the project. So, first of all, we'll start with the main drivers and motivation for the project. Firstly, it is true that the AI architectures for the finance and insurance sector are in the infancy. There is no adequate support for the use cases that demand real-time artificial intelligence analysis. An example of such a use case could be the real-time detection of a fraud transaction as it's happening. Moreover, if we had the tools to support us on these types of scenarios, we still have access to limited datasets for training. This is caused to the barriers that are imposed by the finance sector itself, where the majority of the organizations can be seen as data silos, which do not share data among them. In the same direction, we lack of common sandboxes that can be deployed on top of the testbeds to evaluate these algorithms. The consequence will be that even if we develop novel business models, this cannot be truly evaluated. And even if we were able to do so, we always need to take into consideration the complex regulatory environment of these two sectors of the finance and the insurance. So, what is the results and the value proposition of the project? Firstly, to provide reference architecture for big data and IoT solutions in these domains. It will provide seamless data management over data span across heterogeneous data sources in combination with real-time data analytics. It would offer data harmonization in order to provide interoperability and will allow data exchange solutions based on the blockchain. It will be validated, as Vittorio said before, by 15 large-scale pilots in the finance and insurance domains, validating the proposed business models. At the end, Infinitech will be in position to support the new wave of big data and IoT applications, reducing the inherent barriers for innovations, shorten the innovation cycles, and it can be a true catalyst as we envision it for increased investment in big data and IoT applications. So, regarding the technologies that will be used, you can see a taxonomy of the most important ones. On the bottom layer, there are tools used for the data acquisition and data management. Data can be stored in different and heterogeneous data sources, being operational data stores, putting data to data warehouse via expensive ETLs, to data lakes or other external data sources. All of them deployed in data silos in each bank. And we have to provide both operational and analytical workload. We have a nice scenario that we will be presenting later in this webinar, where we see how the innovation of the technologies that are implemented in the scope of BigDataStack can solve the problem of expensive ETLs to migrate data from the operational sources to a data warehouse. The middle layer provides a semantic interoperability layer that allows for data exchanging. It semantically annotates the data, allows for data sharing between different organizations via the use of blockchain technologies. It relies on tools developed by the bottom layer for seamless data management and polyglot enhancements. And this will allow the whole layer to be considered as a polystone. Finally, on the top level, we see various tools and algorithms that will be offered by the platform in order to serve the needs of the 15 pilots of the insurance and finance sector. These provide capabilities for reporting, data mining, risk assessment, etc., that will rely on the core functionalities of FinTech, such as the provision of incremental and parallel analytics, declarative analytics, the use of core libraries for deep and machine learning, etc. We also need to highlight the tools that will be developed for data governance and the insurance of the data regulatory constraints. So at this phase, the project is at the very beginning, so the priority is to define right now the most important building blocks that will provide us the core functionality of the project. In other words, we are identifying the palette of technologies, let's say, for the platform. In the meantime, one important goal at this phase is the definition of the overall reference architecture. This is still work in progress, however, I can share with you the initial idea behind its design. As you can see, we can have an initial taxonomy of the various blocks that will formulate the overall architecture according to the layers proposed by the BDVA reference architecture. So there are services that lies in the infrastructure itself, in the data management layer, others that lies in the data analytics or visualization, others that can be considered as cross-chatting, etc., etc. The overall deployment is envisioned to rely on the concept of microservices with this wider meaning, let's say. Towards this, its building block can be considered as a microservice that exposes a specific API. We try to harmonize at this phase all these APIs, whether it's possible, in order to allow a more generic combination of functionalities that will not be tightly coupled. Therefore, the user can select from the palette the technology that is inserted and build some sandbox. All technologies will be containerized, and the deployment will be rely on Kubernetes the Kubernetes container orchestrator. In this figure, you can see at your left, for instance, the current version of the palette of the available technologies, and on your right, an instantiation of the sandbox that the user has defined based on this palette. And all this is going to be deployed in the premises on the testbeds so that actually the organization can actually validate the platform. And this is for me, and thank you for your time.
Thank you, Pavlos. That was great. Could I ask Demos to step up and take the floor?
Okay, so good afternoon also from my side, and welcome to this webinar. Before starting, a bit to set the scene, okay, so we talk about data, we talk about data sets, we talk about all the V's of data, and then we talk about AI, methods, algorithms, frameworks, the added value of AI in finance, insurance, healthcare, you name the domains. But for all this to be feasible, for all this to be realized, and thinking that even going further, a step further, and thinking of how all this can be optimized and fit for purpose, we also need to look a bit lower in the stack and see what is happening on the infrastructure level. So, and that's the overall goal and what is the offering and the key advantage of BigDataStack. So BigDataStack is a project that provides several different solutions that can be exploited and which you will be able to listen about later today. But the key goal is that we need to provide an overall system that is data-driven. And this system, of course, refers to infrastructure management and how it should be turned to be aware of the data operations, of the data streams, of the analytics, of the AI algorithms and methods to be executed on top. So that's the overall goal and the main proposition of BigDataStack, and of course it comes with a set of key enablers to facilitate this goal. Going a bit further, what does it mean? So we look into different stakeholders and we provide solutions to different, I would say, classes and cases of stakeholders. A key aspect, as I said, is the data-driven infrastructure management system that facilitates the needs of the infrastructure providers. Now, if you consider that as, let's say, a very bottom layer, this is not the only thing. So we go a bit up on the stack and we see that we need to provide the so-called data as a service that address the data providers, the decision makers, all the private and public organizations that deal with data. And we will come back to this later today with approaches that will be presented, for example, by Joseph regarding data skipping, which is a representative technique we have in our data as a service layer. But we don't stop there because typically nowadays the applications are not atomic applications, are composed applications that also consist or use different data services that they want to integrate into that, as in all cases, in the case of Infinitech, data analytics approaches. So to enable the dimensioning of an application when it comes to the infrastructure to be executed, we need to go a step further, and we need to say that this application is not anymore a typical application that has moved to a cloud environment, but it is an application that includes services that are data intensive and have data operations that affect its overall operation and its overall performance. And of course, you can draw the line over there or say that we want also to address the other two cases of stakeholders, and one of these are the business analysts. The business analysts that are not aware and do not have to be aware of how to implement a specific case I would like to implement for my bank or for my insurance company, but I simply want to provide my flow of processes, my business processes, and this should be automatically mapped to the corresponding algorithms, models, etc., to be executed on the environment. And for that, we offer a process modeling and optimization framework that incorporates also techniques for AutoML in order to facilitate these end-to-end requirements of the business analysts. Whether now BigDataStack is linked only to a specific set of scenarios or a specific set of use cases, or whether it is open to everyone, we also had to answer this question. So for that, we're proposing and we're providing a data toolkit, which aims at allowing any data scientist to ingest, her own algorithm and take advantage of the overall environment of BigDataStack and underlying infrastructure. So, the environment is open, the infrastructure is open, and not linked only to specific use case and scenarios. This is a conceptual architecture. Of course, I will not go through the architecture, but I would only like to highlight a couple of pieces you will see later today. One aspect we consider core in the environment is the ability to be able to execute analytics on top of different data stores, which are by default of different nature, like an object store or an SQL or an NoSQL data store, a CP engine. So we would like to be able to execute analytics, eliminating the need for ETLs. And for that, you will come back later today and you will see the aspects related to seamless analytics. We consider data exhaust, and we see that, accumulating and considering all the data that is available out there, in some cases doesn't add any value, and therefore maybe, skipping specific data set does make sense, and the outcome of your analytics will be the same. So we'll come back to see the data skipping approach today. And, we're thinking out of all these different boxes, what else to show to this webinar. And we conclude that a key aspect of the environment, of this data-driven infrastructure environment, is the way that it uses itself, machine learning and artificial intelligence, both to adapt during runtime, for example, through our orchestration mechanism that exploits reinforcement learning, but also when your new application, the data operations come to be executed on the infrastructure, which is what Richard will discuss about later today. All the approaches about how we conclude to the optimum deployment patterns for a big data application and operation, again, utilizing machine learning techniques. So I would say that the full data-driven infrastructure management system at the end, it is an AI-driven infrastructure management system, and that's a core advantage on this underlying layer. There are different challenges expressed also in different means and different white papers. So, we did this exercise yesterday to look on the different publications and what has been highlighted as a challenge and what should be addressed. I liked a lot, and that's why I put with a different color what says over there that without data, the development of AI and other digital applications is not possible, as highlighted in the corresponding white paper published by the Commission. And improving access and management to data is fundamental. So we have all these approaches across the complete data path, coming from the ingest to data quality assessment, data skipping, and later on to seamless analytics to address this case. Okay, so the management of data in an end-to-end way. In the communication about shaping Europe's digital future, there was, a nice and quite relevant statement, of course, because of the vast amounts of data being generated and the need for high-quality data. So what we propose in BigDataStack is go beyond specific rules and, hard-coded rules that will tell you how and which data are of specific quality. And we propose to utilize machine learning techniques in order to ensure that your data quality assessment and improvement is at the end domain agnostic, and it doesn't really, it's not really linked with specific rules. The white paper about the European strategy for data specifically highlights the need for data infrastructure and technologies. And one of the main propositions is this approach for European data spaces and federated cloud infrastructures. And on that is exactly what BigDataStack is proposing through this data-driven infrastructure management overall goal, incorporating different AI approaches for the infrastructure operations, as you will also listen today, a representative example from Richard. So to summarize this introduction, there are several already ready to use. We believe innovations. The environment has been developed already, and we are, incrementing continuously its functionalities. Several of these will be further elaborated today in the next presentations, and we are happy to invite everyone also to use what we are developing, some of which are already merged upstream, like the developments from Red Hat. So some are already available, and you can download them and use them. Others, of course, are again ready. We will be happy to get you on board and deliver our innovations to you.
Thanks, Demosthenes. If there is any question for Demos, then could you please put your question in the question and answer below at the bottom of this platform. I already see that some of you have found the possibility to do that. And we really encourage you to put your questions there, just so that you have them, we can see them, and we will answer them at the end. Now I would like to give the floor to Jose Gato from Atos, who will set the requirements for the case studies. Jose, the floor is yours.
Okay, thank you. Okay, I guess that you're seeing my screen, in my slides. Hello, good afternoon, everybody. This is Jose Gato from Atos. I work in Atos, especially in the Atos Research and Innovation Department, and I will continue in some way the presentation about Infinitech that was started before by my colleagues Vittorio and Pablos. They did the introduction to Infinitech and these categories that we have inside Infinitech in order to classify our pilots. So during my presentation, I will go in depth with 3 of our 15 pilots that belongs to 3 of these different categories. The first category that we will see is the personalized usage-based insurance products. So this category is for insurance product that the objectives are for the final customers. That could be, for example, myself. In the case of this pilot, focus on providing new services for drivers through an IoT platform or a connected vehicle. And the different companies that we participate there, Atos, Citag, Gradient as technological providers, and Dynamis, that is the insurance company participating. So in the stage of the project, what we are doing right now is to work in the part of the use cases, requirements, and the definition of the business services. One of these business services, for example, the very well-known pay-as-you-drive. So in this pay-as-you-drive business service, what we are doing is to get data from cars, from connected cars, or using an IoT platform inside of our car, and also information from other sources, like could be your trips, or could be information from the infrastructure or for the city where you are driving. We collect all this data into one connected car platform in cloud, where we gather all this huge amount of data. The first thing that we do is to make anonymization when it's needed, in order, because it's very important to keep the privacy in the users, as Vittorio said at the beginning of the FinTech presentation. And of course, we do also typical data management tasks about data gathering, filtering, cleaning data, preparing all the data to go later into our artificial intelligence platform. And this artificial intelligence platform is also an infrastructure capable of preparing all the different artificial activities that we need to do, for example, from defining the models, implementing this model, doing the trainings, analyzing the feedback and the results, training again, and finally deploying these artificial intelligence services and models that are going to be used finally by the insurance company. And in this case, what we will provide is a model that is capable of analyzing the way that you drive, detect if you are a good or a bad driver. Second business service is about fraud detection. It's pretty much similar scenario. The data sources are similar. Again, we use the connected car platform to collect the data, but the main differentiation is the way that we use this data. In this case, what we will do is a classificator of drivers, but not to classify you are good or bad, just to classify different ways of driving or different behaviors. So you are a driver A, B, C kind of driver. And again, to provide a service for the insurance company in order to be able to, in some way, detect who is driving the car, and if this is correct according to the policy agreement that they have with their stakeholders. One very simple example. If I drive my car during 1 year, this classificator will mostly say that I am always the driver, for example, A, whatever that A means. If one day I have an accident, the insurance company could take a look and to see if for example, during this day, the kind of driver in that car was not the driver A, it was the driver B. So something strange could be happening here. Maybe the car was stolen, or maybe another complete different person was driving. The main data sources that we will use, because again, this is about data, or data is one of our main pillars. The main data will come, of course, from cars. We will have with the CITAG, Spanish Research Center, we will have 80 vehicles driving about 4 hours a day, and also they will provide some historical data coming from other projects, about 600 gigabytes of data. Let's see, because this is approximate, because we are now starting. Also, we will have some data from the city of Vigo, that is a city in Spain that is where we are going to implement this pilot. But we will also be able to simulate information from these different cities, because maybe a good driver in a city, the characteristics of a good driver could be different depending on the city. And finally, the data provided by the insurance company. There are many different challenges that we will have to face in this pilot. The first one, from the business service point of view, is that the clients, the users, are willing to have new adapted services. You know, insurance companies works with bad drivers produce some cost that will be balanced with the good drivers. So this could be perceived by the good drivers that maybe during all the whole life they are paying for a service that they are not using, and is compensating the things that are done wrongly by others. So also in the way that this new society is going, in the way that you pay depending on the services that you consume, we need this kind of pay-as-you-drive services. But the data is very important, and to get this data is absolutely no easy. Of course, we have to be realistic. Mostly of the cars that are now driving cannot provide this information. You have to rely on other external platforms. And this also complicates the thing because you have many platforms, many standards, many protocols, and you have to be capable of using the data coming from all these different scenarios. And finally, once that you have the business service, you have the data, you need the data intelligence, because the technology about artificial intelligence, okay, is pretty mature, is right now already there, but how do you use the data in order to do this data intelligence? What does it mean that you are a good driver, for example? This is not an easy, absolutely not an easy question to solve, and we will need the collaboration with business experts about that before going in detail about implementing and using technologies for that. And finally, about the infrastructure, sandbox and testbed that was introduced by my colleague Pablos. In Infinitech, we have these two concepts. The testbed, let's say that is the infrastructure. In the case of this pilot, the infrastructure is going to be provided by a cloud shared infrastructure. It's not on-premise, it's in cloud, that is provided by Nova, that is another partner. Then we will use Kubernetes in order to provide isolation for these 5 pilots that will run together over the same infrastructure, but in an isolated space provided by Kubernetes. And okay, if we go to pilot 11, that is the one that we are talking right now, in this sandbox, they will install the different microservices from Infinitech that can be combined in order to implement the sandbox and to provide these use cases and testing this technology. Just a little break because going to another category. In this same category, we have another pilot that instead of using that is for insurance for drivers, is insurance for healthcare. I don't have too much time, but just to point to that, we have also pilots where the data from the user is still even more sensitive because we are talking about healthcare situations. Now I move to the second category, that is personalized retail and investment banking service. This category is more related to financial and banking services, but the final user, well, the objectives of these services are final users, again, like it could be myself interacting with my bank. In this pilot 5A, the bank is Liberbank, and they will collaborate with GFT, University of Piraeus, and Crowd Policy in order to implement the pilot. The intention is to create a pocket assistant that will provide different smart services. For example, small alerts that will prevent you about possible overdrafts, will detect or identify recurrent payments in order to offer you the possibility of doing this automatically. It will protect you, alerting from potential anomalies because the bank knows their customer and can detect things that could seem very strange by this customer, and well, this other kind of smart services. The architecture that is in this slide, I don't go in detail because, of course, it seems very complex, but I don't have the intention of going in detail, but you can just take a very quick look to some of the technologies that they will use. But the important thing in this architecture, in this picture, is the data sources that they will provide. For example, they will have customer profile information, that's just your profile as a customer of a bank. Also, they will have the personal financial management information. That is your your transaction, the products that you have with your bank, etc. It's all your historical information in the bank, and also the bank products offering data source. They will combine the three different data sources with different technologies. They will use big data technologies, artificial intelligence, etc., in order to implement this pocket assistant for smart alerts, smart recommendations, etc. One very quick example again, and something that seems very interesting, is they will use your customer profile and your financial profile in order to do a kind of clustering of similar customers. So this seems interesting in the way of offering services and products that are working for other customers that are similar to you. So maybe if this worked for them, maybe it also could be interesting for you. But this is just one example. About the sandbox and testbed, is the same that in the previous pilot. The only thing that I would like to remark here, in this case, for example, for them, it's still not clear if the testbed infrastructure will run in cloud or on premises. Maybe they will go for a mixed solution, but it's expected that most of the things will run on premises in Liberbank. But again, they will use Kubernetes and this microservices architecture to implement the sandboxes for Infinitech. And I'm just finishing with the third category, that is financial crime and fraud detection. Is the pilot 9 of Infinitech, that is named Analyzing Blockchain Transaction Graphs for Fraudulent Activities. The bank that is involved here is Aptic Bank, and their intention is to, they will take blockchain as a technological data source, and they will use different blockchain implementations, like could be Bitcoin, Ethereum, or other ones that are more regulated, like could be GUSD. And the idea is to detect the fraud in the final transaction. So when you are moving virtual coins from different platforms, and finally, when you're trying to move this money into a final bank to convert this money into real money, is where they will act, and they will try to detect if there is something that could be wrong. How are they going to do that? What they are going to do is to build a huge, you can imagine, a huge graph combining the different Bitcoin, Ethereum, USD, different data sources. To build this huge graph, they will extract all the addresses of the people or entities involved in these transactions, and they will check this against some existing blacklist. So if you are inside of this blacklist and you are trying to do this last movement, you will be detected, and this will be analyzed, studied in deep, or maybe it will be not allowed. So as you can imagine, these are the number of transactions is huge. We are talking about hundreds of millions. So the graph will be huge, and the high-performance computing demands for this pilot, they are expecting of needing for this testbed like around 30 nodes with terabytes of memories. So it's very challenging from a technological and high-performance computing this pilot. Here I don't go in detail, but some of the technologies that they will use, of course, technology related to blockchain and getting data from blockchain, how to build these huge graphs, and how to interact with this graph in order to do visualization, to reports, analysis, etc. And finally, the architecture. Again, I don't go in deep with that because this is the, let's say, architecture of the pilot. This is the regular architecture. This is not the, let's say, Infinitech architecture. One of the things that we are working right now in our project is moving from that to this reference architecture of Infinitech that was also presented before. We will have a common reference architecture for the 15 pilots, And also we are doing an effort that this reference architecture and the different layer will match as much as possible as the BDVA architecture. So we are moving from this to something more general like this one, with different small pieces that later could be implemented as small microservices that will run into this sandbox. And okay, for me, that's all. Just as summary, the idea of this presentation is to present 3 of these 5 categories and to present 3 pilots of the 15 that we have in Infinitech. As you have seen, they are very different. We cover very different scenarios and very different technologies, from some scenarios more related to IoT and artificial intelligence, or other could be more related to big data, other more related to blockchain. Okay, that's all from my side.
Thank you, Jose. That was very illustrative for the webinar. So what we've seen until now is that how both projects add value, what their key offerings are, and how they contribute to Europe's digital future. Jose just now set the requirements for the use cases, and now I would like to invite Richard, who will give us the first technology of BigDataStack technologies that are fit to address the requirements that are just illustrated by Jose just now. Okay, Richard, the floor is yours.
There we go. Can you hear me okay?
Yes.
Good, right, okay, so let me just slide the right thing. There we go. Yeah, my name is Richard McCready. I'm from the University of Glasgow, and as part of the BigDataStack project, I lead the development of a series of components which we call the application and data services. And what I'm going to talk to you about today is how these can help make it easier to deploy big data applications in cloud infrastructures and help automate that process. So to begin with, I need to introduce some concepts. So you will have heard in this webinar already some terms getting thrown around in terms of containers, Kubernetes. I should probably introduce what these are. So if we think about how big data applications are currently being deployed out in the real world, the best practices in industry are to deploy these as a series of what are called containers. So these are effectively, we take our application and we build it into a small atomic unit that we can use for management. These are really handy because they provide a standardized means for all of our compute that we have. And they're also shareable, and there are many turnkey solutions that we can just download off the web. So we have sort of off-the-shelf solutions. And so these are commonly used in industry, and they're good for deploying our big data applications on single machines. However, as we start to scale up these applications to deal with ever larger data streams or more intensive compute, such as current deep learning approaches, we often need to move into a cloud or cluster-based environment. And so we need additional management to help orchestrate that. So this is to do things like enable scheduling, provide better communication between different containers, which are maybe running in different zones, manage and make sure our storage is available, as well as enable scaling and load balancing of our applications based on the data or requests that we're getting in from our users. And there are a variety of current management tools out there. Inside BigDataStack and also Infinitech, we use Kubernetes as our base, which is the most popular one. So Kubernetes is good. It provides us a basis for managing containerized applications in the cloud. However, there are some limitations that Kubernetes comes with that we're trying to overcome in BigDataStack. So to help illustrate this, let me give you an example application in the finance domain. So let's imagine that we're an insurance company. And what we are trying to do is we are providing insurance policies to customers, and they will periodically make claims, which may result in us paying out back to the customers. And what we might want to do is, periodically during the lifetime of a customer's policy, we might want to go and predict the likelihood of the user going and making claims, and hence whether or not we are going to make a monetary gain or loss for that particular customer. So are they paying in more than they're likely to take out in claims? And using modern technologies, we could do a form of prediction here using some kind of deep neural network, combining past claim history from them and other users like them, in addition to other open data sources. And we might then want to update that neural network to make sure we get the best performance over time. So what might this example application look like if we were to deploy it on a cloud or cluster infrastructure? Well, we might have three main components. So first of all, we have to get our data from somewhere. So we have maybe a claim storage and open data collection component, which is streaming in real data about the world and about our claims and storing those in a database. We then might have our learning component, which is going to take the data that we're coming in, so our claims and our open data about the world, and are going to produce different learned models and try and effectively find the best quality learned model that's going to have the least prediction error, right? Because if we can identify customers where we're going to lose money, maybe we can take actions to try and improve that situation. So maybe we try and upsell them into a more expensive policy, for instance. And that would be our third component, where we look at the current policies, and then maybe at periodic points in time, we could say, okay, I'm now going to try and predict whether I'm going to gain or lose money on this particular policy or customer, and I can then maybe trigger actions on that. So maybe I send an alert to the sales team to say, for these customers, I think I'm going to lose money, and hence maybe I should try and upsell them into a more expensive policy. So that gives you kind of an idea of what an application in this space might look like. We have a range of different containers that are doing different jobs. They tend to be quite data intensive, and they probably have quality of service constraints that are placed on them. So for example, we need to have near 100% uptime on our claim ingestion, for example. For our AI component, we want to evaluate the quality of the model. So effectively, how accurate is it at predicting whether or not we're going to lose or gain or lose money from a particular customer? And so the natural question then is, how easy would this be to deploy this type of application using a platform like Kubernetes? And the answer is not very easy, as it turns out. And this is because it doesn't provide the tools to manage these type of complicated applications. And this is for four main reasons. One, there's no central definition of a multi-component application that we can centrally manage. You effectively need to deploy all of your components in a sort of a la carte manner, which makes it very difficult to manage. We also have no inbuilt sequencing of operations within our application. This is problematic because we then can't do things like wait until our data arrives from maybe some external data store, particularly if we're dealing with very large applications. Moreover, if we have an inexperienced user who comes along with a new application, they need to understand, well, what resources do I need to request from the cloud or cluster infrastructure to enable our applications to run? And that can be very difficult for them to do. They need to deploy their application and test it. And so ideally, we'd want to have some way of trying to improve that. Moreover, there's no inbuilt monitoring for these types of applications. So effectively being able to tell, okay, is my application meeting various quality of service constraints? And so we want to be able to provide tools to enable that. And so the Big Data Stack application and data services are there to effectively provide practical tools to try and make tackling these use cases a bit faster and easier. And it does this in sort of 5 main areas. So first of all, it allows us to define high-level applications comprised of these different components and manage them centrally, as well as define a simple format by which we can automatically deploy these, which we call Big Data Stack playbooks. It provides support for operation sequencing. So this allows us to queue up different sequences of operations and where we may have delays while big data is getting moved around. We also have a standardized means for collecting metrics, storing those and visualizing them. So effectively it means that we have a one-stop shop place where all of the information about an application is stored, and hence we can use that to both visualize and maybe trigger operations from. We provide an additional set of components to estimate the resources that an application may need. And this is based on machine learning technologies, where it tries to estimate resources based on other applications that are similar to yours. And we also provide a centralized API that provides direct access to all of the metrics that we're collecting, as well as operations that we can apply on the particular applications, where these can be predefined. This is very useful if you want to then put business logic on top of the framework. In terms of what the application data services provide, it's all built on top of Kubernetes. And for BigDataStack, we also use OpenShift, which just provides some additional tooling. In terms of the framework itself, it comes with a few key components. The central heart of the application and data services is the global decision tracker. And what this does is it holds the state of all of your different applications and the different components that application is comprised of. So this allows us to centralize all the information about your application. It then exposes two ways that people can interact. So it has the actual application API that allows you to request metrics or state of the application, and allows you to issue commands to go and alter your application. And it also exposes an event exchange, which generates different events as state changes inside your application that you can use for triggering operations, or maybe, for example, if maybe quality of service fails, you can use that to maybe trigger some alteration to your application. We then have a realization UI, which sits on the top, and this is just a way to visualize the information from the global decision tracker. We then provide a series of services that sit underneath that. So we have the OpenShift client for performing operations on the cluster itself. We have the resource estimation component that uses machine learning to estimate the CPU, memory, and potentially GPU resources that your application needs. And we then have the monitoring subsystem that provides a standardized way for collecting metrics, both about the containers, so maybe their resource usage, but also any custom metrics that your application wants to expose. For example, the effectiveness of your machine learning model, or the uptime of your application, or the latency for user requests. So coming back to our insurance loss estimation example, where might the application data services actually help? Well, all of the components inside that complicated insurance application can be defined using a single big data stack playbook, which can be uploaded to the system and then deployed and managed automatically, reducing the amount of time that we need for people to actually go and manually deploy and manage all the components. We have operation sequences, which allows us to order the deployment of different components or wait for different state changes. This can be useful, for example, if I need to wait for a database to receive all of its data for maybe external sources before I start some other operation, like learning my new insurance estimation model. The standardized metric collection gives us a one-stop shop place where we can store all of the information. So for example, component uptime, our learned model performances, and potentially we can use that to trigger different operations. During deployment, if we have users who don't know what their application needs in terms of resources, we can provide reasonable defaults for that using our resource estimation component to try and reduce resource wastage and basically over allocation of resources from particularly cloud environments. And we can use the API to basically provide an endpoint to which your business services can connect to allow you to trigger things like scaling up and down your application based on load, or maybe to trigger model learning at different stages, or these type of operations. So where are we going with this? Well, we're currently in an alpha version, and we're testing this using two different applications in the BigDataStack project. So for gross range product recommendation, as well as for insurance estimation. And we're planning to have an open source release of this framework before the end of the year. Thank you.
Thank you, Richard. Any questions for Richard? Please put them in the question and answer box at the bottom. Now I would like to invite Yusuf Moati from IBM Research to present the data skipping technology. Yusuf, the floor is yours.
Hi everyone. Good afternoon. So I'm from the IBM Haifa Research Labs, and we will discuss one of the technologies that have been developed in the framework of the BigDataStack project, and this is datascaping. So, excuse me. So what the technology context? We are dealing with this big structured data, maybe semi-structured data. They are stored in object storage, which is the storage of choice for cloud. This data is accessed through Apache Spark, which is one of the most popular big data analytic engines, and more specifically through Apache Spark SQL. Now, we have to understand that modern big data architectures decouple storage from compute clusters. Therefore, big data analytics implies potentially big data transfer. And therefore, datascaping is important for this data analytics. And because in fact, what the goal of datascaping is to reduce the data transfer, which is done from the object from the storage cluster to the compute cluster. So just getting back, we will see in the following that this technology has already been incorporated into IBM products, which highlights its importance. So how does it work? First of all, the goal is to find out objects which are not relevant for a given SQL query. This is done by ahead of time creating an index for all the objects which pertain for a given data set. So this summary index metadata is associated for each object, and it is important to notice that we didn't change Apache Spark, the base code. So how do we get in? We just take advantage of an Spark external API, which permits to refine the set of objects which are relevant for a given query. So as we said, we skip over irrelevant objects, and moreover, these objects are not touched at all. We don't retrieve any header, which would mean that although the object is not read in entirely, it takes time to read the header. So we don't touch it at all if the index shows us that this object is for sure not relevant. So this data skipping technology is state of the art. To our best knowledge, most of the features that I will show you now are unique for now in the data skipping of IBM. So what are we speaking about? We support user-defined functions. We support general regular expressions. We have multiple base indexes, such as Bloom filter, main max, value list, etc. We have also the possibility, we give the user the ability to plug in its own index. So, and many other features. So all this, the bottom line is that by reducing the data transfer, so we save time and money, because typically the bill is proportional to the data transfer. So I will give you a very small example of a SQL query that we demonstrated. So this query comes from the Danhaus use case. This is one of the BigDataStack partners. And so as we see, this is kind of trying to find out data for a given wind speed, with speed of wind. And here, what we can see on the figure is that the where clause is in fact translated into a way to weed out non-relevant objects, and this finally is translated into transferring a small number of objects which all pertain to a given data set. So this slide shows the maritime use case that we demonstrated in the interim review of BigDataStack. This is quite a few components. As you can see, what interests us is in terms of datascaping in this part of the right side of the object. So what we demonstrated was with the Danaus vessel dataset. I mean, which has been brought within the project by Danaus, and so we ran many queries that were typical of the use case and of Danaus, and the object storage could have been local. It can also be remote, which was the case in our demonstration. It was in the US, and what we demonstrated was a reduction in the data transfer of up to 99%, depending on obviously the query and also the data partition. Next, this technology has already been demonstrated exactly 1 year ago in the Think IBM conference of last year. This technology has already been introduced in quite a few IBM products at various levels, open beta, closed beta. In fact, although I'm not, I couldn't say when and if this technology will be GA, but I wouldn't be surprised if it will be even quite soon. And finally, we are preparing a scientific paper which should be submitted soon. So our next steps are in fact to improve our data partitioning. I didn't explain this for lack of time, but this is also an important part of this technology. We obviously want to push for additional adoption, and we also have quite a few technological improvements that we want to put, such as decoupling this datascaping from Apache Spark and to make it available to other products. Finally, this is a team, and thank you very much for your attention.
Thank you, Youssef. Now I would like to open the floor to Pavlos Kranas from LinuxScale on the seamless analytics. Pavlos, the floor is yours.
Thank you, Marek. So, hello again. Also, LinuxScale participating in the BigDataStack project, and we are leading the task of, we are participating in the task of seamless analytical framework, which is a joint task, a joint effort between LinuxScale and IBM. So we continue from Can you hear me?
Yes.
We continue from the floor that Joseph left us. So in a general picture, a modern enterprise makes use of several different types of data stores, right? So we have operational databases that are designed for OLTP load, which is the operational load. We also have key value stores, mostly ideal for IoT data. We have data warehouse where we take data from operational databases to perform data analytics. We have also data lakes, etc., etc. what we actually need is the applications to have polyglot capabilities. They don't speak one language; they have to speak different ones and access different kind of databases. So, how we do it nowadays? Usually, a scenario is to use a data federation mechanism. Most likely, would be something like Spark that uses on top and execute query, combine the results. It might be very prompt for data analysis. However, this can be very resource consuming, and for instance, might need also to take all the data from the different sources into the layer where Spark's PR have deployed the workers. So it's very consuming about data transferring, and also it's true that cannot exploit the specific capabilities of each of the different type of data stores. So this is what we try to solve in this seamless analytical framework. So what is the data story? Joseph showed before a slide about the data journey from one of the use cases that we have in the BigDataStack. So we have data that comes from different parts from different IoT sensors and being ingested into the operational data store. Why we need an operational data store? Because we need transactional semantics. We need to have data consistency. And the data ingestion comes there. But as the time passes, some data becomes historical, becomes obsolete, and they are very rare to have any modifications. These scenarios, let's say that we have different IoT sensors, data coming from IoT devices, the data coming from logs, let's say from the internet, but data that comes also, let's say, the orders of e-shop according to the TPCC benchmark, let's say, which simulates a variety of a lot of e-shops of this kind of e-commerce. So this data becomes historical, and we need to have analytics on top of that. So what happens when you have real big data? We usually move them to a data warehouse in order to perform analytics there. Data warehouses are perfect to do that, but they don't support operational transactional semantics. So how we do that? We distribute data sets from one to the other. But this is problematic because data, if we want to have a specific analysis, you have to be retrieved from both of the stores. So if you have only the data warehouse, you lose the current picture. You only have data that is the snapshot when you take when you have the last movement. Also, if you had to take them from both of them, you have to merge them in the application level, which is something very important, very difficult to do in an application, because this is something that databases are about to do. And also, when moving data sets from one part to the other, we also need to take into consideration the data consistency. So what we propose here, what we have developed this seamless analytical framework that actually be used to federate data from two different types of data stores. We have the hybrid transaction analytical processing relational Linux scale data store, and also we have the IBM's cloud object store. We have one operational and one analytical databases. They are designed to be good at what they are doing best. So we have the same data set that is being shared between the two of us. So from an application point of view, we have a single black box, let's say, component, a single logical data store that consists actually of two different physical ones, that this one can exploit the unique characteristics of each one of each of the two data stores. So we have Linux scale for having the operational behavior and IBM to have the analytical behavior. This is totally transparent from the user, so the user can see everything as a logical data store. And also, we do not compromise the requirements from the benefits of the others. So we downgrade the transactional semantics in order to be able to achieve this level of analytical processing. Neither we downgrade the analytical processing in order to have some semantics, the transactional semantics. So how does it work? Let's say we have two different, as we see here, we have the two different stores. We have the Linux scale and the IBM's cloud object store. On top of the object store, this is, as Joseph said before, with Spark, which exposes JDBC interface, and we have the extension of the Linux scale query engine, let's say the query federator that speaks with both of them, submits the query, then retrieves the results, merge them, and returns back to the application. It exposes also a standard JDBC interface, so from the application point of view, it's like exactly like having a relational data store. So an example here is how we execute the query. Let's say we have a select statement from a data table with a filter. So this actually performs a scan on the table with a filter operation. So as we say, we target the data sets that are coming from IoT devices, from let's say from orders, etc., etc. So this means that they have timestamps, and we move data according to one timestamps from the operational to the analytical one. So let's say that the timestamp is set to the 1st of January of 2018. A query has been submitted like that to the query federator, which is the one that exposes the interface to the application. Then the query has been rewritten a little bit, taking into account this information so that can access and scan a specific type of dataset from a Linux scale, and there's a specific one from the object store. Also, you can see here that also we use Apache Thrift in order to be able to provide and store the common metadata catalog so that at the very end, everything can be fit together. The two results are being merged into the Linux scale federator and returned back with the standard results as you can expect from a JDBC interface. So what is the supported operation right now? Firstly, we supported the full scan. Full scan operation can be executed in a distributed manner. We have a table that's been fragmenting in both of the stores, so a scan can be executed like scanning the one, scanning the other data store, and also return the union of them back. We also can support order scans because at the very end, you order both of them. You scan them, both of them with respect to their order, and then you combine the results at the federator and return it back. We support limit, we support aggregations, group by, order group by aggregations. Aggregations is a very tricky point here because aggregations actually what we require. We require a full scan of the table and also perform the aggregator operation on top. So how can this be executed? Let's say we have a select count from whatever table. So we need to see exactly how many records there are. This can be executed in a distributed manner, because if we push down this operation to the two different data stores, then you have the count from one, the result of the count of the other, and at the very end, it's the summary of the two counts what it matters. Also, if we have a summary aggregate operation, the full summary is the summary of both of them. In the same way, the minimum is the minimum of the two intermediate minimums, etc., etc. However, the average operation is something that cannot be executed in a distributed manner, because the overall average is not the average of the two intermediate ones. However, the average is actually the summary divided by the count, and these operations can be executed in a distributed manner. So actually, when you have this, we can change internally and execute it in a distributed manner and return the result. What we cannot support yet is a join operator, taking into account that one of the two operands is a distributed table. It's a table that has been fragmented. Actually, it supports, but in theory, but we cannot actually put it in practice, because the way it has been implemented right now, it would require the result of one opera to be actually in memory, and then to be able, so that it has to be there. So we cannot exploit, let's say, data pipelining techniques in the execution of the query. So we need every results in memory, which, because it's a table that's been fragmented, it's a table that requires a lot of petabytes, so the system will crash. This is a work that's been actually currently done by Linux Scale and IBM in the scope of the project, and going to be delivered in the next period of time. So the query federation is one part. The other is how we actually achieve the data movement. You can see here that there are different components. We have the Linux Scale operational data store, we have the IBM Cloud Store, we have the data federator, as we said before, both that pushes down the JDBC, the queries, and returns the result. We have the data mover. Additionally, it actually takes responsibility to move the data from one to the other, and the data manager would actually orchestrate the whole process. So what is the flow? The flow is that the data admin just can configure the system to do this periodically, this movement of the data periodically. So it doesn't have to intervene, and everything's going to be done very transparently with respect to the whole application. So when the data should be moved, the data manager informs the Linux scale that this data slice should be moved. What happens internally is that this is being marked as a read-only right now, and no other write operations can access them, and be moved to a specific data region internally in the storage, so that can be dropped later much more easily. Then there's an information, these signals have been implemented using a RabbitMQ right now, and this information for the data move that is be able to take the query, to take the data. And then the data mover actually executes the SQL statement that has been also informed to grab the data, open a standard JDBC connection from LinuxScale. As this data are marked as read-only, this is very quick, and the data are being fetched very quickly to the data mover. Then the data mover is building the data skipping indexes and everything that Joseph was telling you before in order to store everything into the object store. And then at the very end, when the data are persisted, it informs the LinuxScale that now it should be able to drop this data slice. We have to take into consideration here that everything is being done with the principles of distributed computing. So in any case, even if a message is been lost and the data slice is not moved, at the next phase, when the next slice should be moved, eventually everything will be dropped. So we ensure that without any interference. And when actually it will be informed that the slice should be dropped, then actually we just remove this specific region, like erasing a file from the file system. What is very important here to highlight is that in the whole process, we ensure the data consistency, which means that at some point data might coexist. When data is being moved from LinuxScale to the IBM, data maintaining LinuxScale. So actually when you execute a query and you need to scan a table of 100 records, let's say, you do access and scan all of them because data are still in LinuxScale, are not dropped until it's been eventually stored. However, there is this slight window here that the data might coexist in both of the stores because they are also in the object store. How we do that? Because the federator also takes into account where is the splitting point, and actually each transaction that comes and accesses specific data has its own visibility of the two fragmented sets. And how we achieve this? Because it is an extension of the LinuxScale query engine itself. So this means that also takes into account the transactional manager of LinuxScale. So the transactional manager ensures the ACID properties in the database theory, and the ACID properties we have the I, which means isolation. So all the transactions can be executed in a serializable manner because we ensure that by the transaction manager itself. And I can go very, very deeper into the technical details here, but I'm not sure how it's the background of the attendees. So I would be glad if you have any more technical question to ask me, and I will answer later. And thank you.
Thank you, Pavlos. So now you've seen off-the-shelf solutions, and I would like to ask Marco Rotoloni to tell us how such off-the-shelf solutions could contribute to Europe's digital future in FinTech and InsuranceTech. Marco, the floor is yours.
Thank you. Let me share my screen. Okay. Okay, do you see me? Do you see the screen?
Yes.
Yes, Marco. Okay,
perfect. Okay, thank you. First of all, to the organization, then to all the speaker, because I found very interesting to understand how vibrant is in this period the context about the development of solution based on big data and artificial intelligence. So probably we are in a context where really we are looking to extract the untapped value of data, and to do this, it's important that we put all these experiences, all this work together in order to understand from a top-level view what is the situation and what is the possible evolution of the context at European level. I'm Marco Rotoloni. I work from Abilab, that is the Research and Innovation Center of the Italian Banking Association. And together with GFT, we are the leader of a task force promoted by the BDVA that aims to develop a white paper on artificial intelligence, big data for financial sector. Because we saw the financial sector, the financial services are very impacted by the new trends of big data and artificial intelligence. So what is the starting point? the BDVA asked us to somehow set the scene about the main challenges and opportunities related to big data and artificial intelligence in financial sector, trying to understand what should be the vision we have to follow towards 2025. To do this, we are thinking to develop two different approaches. The first approach is top-down, starting from the analysis of the scenarios that maybe also at the European Commission level it's starting to develop. Many of you maybe know that the European Commission developed a white paper on artificial intelligence, and it's starting, has put in consultation other papers, for example, about the data strategy and the implementation of a trustworthy AI framework. So there are some considerations that we can take from the research, from the institutions, but there are also the lessons learned that we can take from a bottom-up perspective, because many projects are now being developing. There are many actors that are working on it, and in particular we want to capitalize the value of the flagship initiative of the InfinTech project that has been described before, in order to understand what can we learn from the different experience, from the different use cases that we want to develop. The importance of this document is that we have to take of the actual situation, but necessarily we are going to develop a living document, because as the situation evolves so fast, so fastly, it's impossible to freeze all the consideration at one moment, but it's important to maybe continue working on it, continue discussing on those issues, and consider what that we are doing as a starting point for a further evolution in the next years. From a general point of view, so we think that the approach should be necessarily focused on a knowledge sharing approach, and on building an ecosystem of excellence about the development of big data and artificial intelligence solutions. Because our belief is that if every actor that in Europe is following this teams, these approaches, if everyone puts together their knowledge, their expertise, and their research activities, it's possible to generate a bigger value for the whole ecosystem. In general, we can use the use cases as references, not only to understand what are the possible areas in which we can implement solutions, but also to extract some concrete recommendation on how the different use cases has solved some of common questions that can be raised by the use of the new technologies. So the position that we are going to build will use in different ways. Will be used, first of all, at the BDVA level as I would say, a dissemination paper in order to let everyone know what is the frontier of the innovation driven by big data and artificial intelligence. Second, to influence the European Commission white papers and to set the reference for the further development of the financial strategy. So using this document as a communication instrument between BDVA and the European Commission is certainly something that we want to achieve. Also because we believe that starting from what we learned today, we can suggest some ideas to the European Commission also for new projects like InfinTech to be developed in the next period. From the practical point of view, so this is our vision, of course, very, very important to underline, but from a practical point of view, how are we working? So we started from the BDVA community and infrastructure. BDVA has already a lot of contacts between expert, researcher, and technical practice owners all around Europe. So we started from that, and we selected a task force of participants based on what were the interest in participating to this initiative by different BDVA members. Between this task force, we identified the core group. So some participants that are very deeply skilled on those issues that are following research initiatives and that are followed some interesting projects about the development of these technologies. And this core group should be the first level of action that we will contact to provide us input and paperwork to develop our paper. Of course, between everything, there is Bilal and GFT that act as a chair and coordinator of this task force. So, the structure of this paper, what are the issues that we want to address? Okay, first of all, I should say that it's important to introduce the issues, to make an introduction that describe what is our vision towards 2025, and is the part that I described before as the top-down part, in which we want to understand what are the position that the main actors at the level of the European ecosystem are developing, and try to understand what should be our strategy in this evolving context. Then we have to describe the state of the art of the technology of the project that we are analyzing. In particular, we want to focus both on banking and insurance market, that is the more traditional, I would say, actors that are providing financial services. But also we want to look at the FinTech and InsureTech phenomena that probably are not so big, not so strong like banks and like insurance in the possibility to develop solutions, but they are very fast, they are very innovative in some services, and so probably we can learn something also from them. So let's understand what is the scenario of those actors, and let's analyze what are the existing technology that we can consider, and the emerging technology that maybe at the moment are not still stable, are not still so reliable, but they have a very high potential in growth towards 2025. And of course, we have to identify what is the regulatory environment. So we have to study the directives from the European Commission, from the European banking authorities, and from all different authorities that have impact on the banking and the insurance sector. This should be very important also because the scenario of the possible technology is very wide, is very big. So we have also to select and to understand what we want to focus on. In particular, if to make a deep dive on the artificial intelligence techniques that now are more common, such as machine learning, for example, or if we want to see also opportunities from new models of developing artificial intelligence that maybe are not so standard and could drive innovation in the future. Of course, the study of the state of the art will lead us to identify some challenges, because it's important that in this paper we highlight also what are the barriers that now are slowing down the process of innovation. First of all, there are some business challenges, for example, considering the need to change also the change management processes inside banks, the need to work in agile methods using, for example, development techniques that can leverage on DevOps and new developing models. That's because sometimes it's not easy for banks to change their common behavior, and working on this new technology requests to be very fast, to be very rapid in try, fail, and try again a new solution. Of course, there are some technical challenges that are related to the technology itself. For example, consider the matter of explainability of the enterprise of artificial intelligence. That probably is something that can be a problem in the dialogue between banks and the regulators. Or let's think, for example, about the problem around the bias that can affect a data set, or considering the aspect related to security, cybersecurity, and aspect of reliability of the systems. In technical aspect, for example, you have to consider also the cloud problem, no? Because right now using cloud is not so easy, also because the data should be compliant to different regulations such as GDPR. And also there are some non-technical aspects that probably are with regards to skills, competencies, to the regulatory environment, and to all the aspects that maybe can lead a gap between what are the skills that we need to develop this new technology, and what are the skills that we have now. Between the challenges, we want also to address some recommendations on how to go over these challenges, and of course some conclusion about the work. An important part of the paper, of course, is the collection of use cases, because we want to not only to make a paper such as a descriptive paper that highlights, I would say, a research approach, but also aggregate this descriptive paper with a collection of concrete use cases in which we want to map the motivation and methodology that have been used, the technologies, the outcomes, also in terms of KPIs, and the challenges of these use cases. We have asked every partner of the task force to provide us 1, 2, 3 use cases in order to get a collection of use cases that can help us identifying the recommendation and offer to the community a list of the scenario where we stand, what we know, and what is the actual situation of the project that we are developing. Just to be fast, because probably we have not so many time, the interaction is the core of the participation of this task force. So we develop a sort of timeline that started a few days ago in May, in which we started in consolidating this structure of table of content and assigning a sort of homework to the task force core group. The task force core group will write the first draft of the paper and will provide us the first draft of the use cases description in the next 2 months. And in July, we want to close the first draft of the document, have another meeting with all the task force, and start the first revision process that will take place in August. And we'll finish in September with the second draft that should be again put under a revision, a refinement process, and finalized in October. So that more or less our idea, our path. If you have some questions about this project and about the content that we are developing, please feel free to ask me some questions. Thank you.
Thank you, Marco. While we are starting to prepare for for the questions and answers moment. Marco, can I ask you to stop sharing the screen so I can show a few announcements, and then we start with the questions and answers. So we open the floor. We have already a few questions in.
Okay.
Thank you. So I'll start. So I just want to point you out to the ICT standards to combat the coronavirus initiative. So the task force of the rolling plan of the ICT standardization is working on a special chapter to identify the need for ICT standards to combat coronavirus and to support the recovery of the European industry. So the task force itself invites you to share practical suggestions you may have. So during this webinar, we already saw the envisaged exchange of health data in a secure way in the Infinitech pilot as an example. Then after the webinar, what we want to ask, what we will do is we will send you a mail to invite you to respond with suggestions, and these suggestions will be shared with the task force. And then I would like to point you to these three webinars because we are in the series of the BDV PPP Summit 2020, the virtual summit. They are pulling out an amazing amount of webinars. Here are the next three. Put them in your agenda, join them. They are very interesting. And the BDV PPP Summit virtual exercise is a great way to engage, even though we couldn't be in Porto. So now I would like to have a look at the questions that you've asked. Let me see if I can pull them up with the screen. Okay, so I've seen, Dimos, you've already answered some of them, but let me read them out so that we can have a discussion. So for data as a service, what are Savita Majukumar, I'm sorry, I hope I pronounced your name correct. You've posed a question on, for data as a service, what are the typical data sources that you rely on for insurance industry? How many insurance industry players consume the data currently, and what is the pricing model like? What about the customer consent to use the data? Dimas, you already provided an answer. Do you want to elaborate your answer a little bit, or do you want to give it to Infinitech at this point?
Well, I replied, but I think it's mostly related to Infinitech, given that it addresses, in a wider extent the insurance industry. So I only gave the view from a big data stack and how we are also handling different types of data sources. But I guess it's mostly related to the work of Infinitech and what Jose presented.
Jose, can I ask you to elaborate, or Vittorio?
Okay, I think it's not easy for me to answer because I guess that if we talk about the typical data sources that they are already using, I don't know if this question points to that, or if this question points to the concrete case of Infinitech, where I have explained some of the data sources that we will use for this pilot. So I think I don't understand very well the question.
Maybe Savita, if you are on the call, do you want to elaborate this a little bit?
Just also to complement on what Jose was telling, also in Infinitech we target four different type of, we target as of now 4 different pilots in the insurance industry. All of them are quite different, and that's also Dimos mentioned in the answer. It also combines data that are specific of the user, of the people that are in the insurance company, and also the open data regarding the climate, regarding the weather conditions, regarding how it's the topology if there is an agro insurance company, etc., etc. So it's not something that we can actually, it's the platform that we are targeting. It's mostly specific to the industry company that goes into the platform.
Yeah, it's difficult to answer because it will depend in each company. For example, the insurance use case that I presented, and the insurance company, they will provide their own data or statistics that they already have from their customers in order to build these final users, the final services for pay as you drive, the tables that they already have. But this is not enough. They will need, for example, the data from the connected vehicle. That this is something that is not a matter of relay or not. This is something they don't have right now. And the problem is that maybe by themselves, maybe they are not prepared to have this data, and they need the collaboration from a technological partner or someone that provides a platform, like it could be CTAG, to bring this data into their system. And this is only just one case from the 15 that we have.
So basically, hi, Sabita here. So basically, my question was about, whether there are any insurance companies actively using this data now. I mean, you are offering this as a service, but is anybody using this, or are you just providing the technological capabilities for that?
Exactly. It's about the technology and the tools to actually operate and make the analysis of the data. But the data is on the industry pilot, on the industry company. So the consensus of the user is also provided to the company that just use the technologies to make better the analysis that they have.
I see. So you are not actually coordinating say, set of data sources, and then, you are bringing in all the data and then analyzing it and then offering it as a service. It's not really that. It is actually data as a service technology that an insurance organization can use. Is that what you're saying?
No, I think that Pavlo's answer was that, up to the point that the data gets to the insurance company, and this, for example, includes the consent from the users or the customers, this is what we don't tackle. Of course, we have, now I'm talking about BigDataStack, right? And the data ingest process and then the full data path. We do have the technologies to get also data directly from streaming sources, which we do for another use case. So it doesn't mean that we only address specific data stores at which the data of insurance companies and customers will reside, but we could also accommodate direct input of the data. And then you have your own algorithm, your analytics that runs on these data sets directly. Now, where to deploy, whether this full stack will reside, on an offering on a technology provider, or whether you deploy your full stack in your insurance company, both choices are valid.
So will multiple insurance companies consume the data as a service?
Correct, indeed, yes.
And the data sources are not the actual customer data of the insurance organization, but probably you are accumulating data from third-party sources and offering that to insurance organizations for analysis.
Right. So because we also have an insurance scenario in BigDataStack, in this case, it's data that comes, the first is from the insurance company, and the second is other types of open data, like, geolocation, etc., that are aggregated in order to make the predictions and the classifications that are required by the scenario.
Okay.
Yeah.
Thank you.
It will depend on different data sources. So some data sources will be provided, or you could say that are internal to the insurance company. As my colleague have said, we don't tackle into that in the project. What we will do is to get data from external data sources, like could be some open data or solo data coming from an IoT platform, for example. We will gather all the data. We will test or pilot in different technologies to manage this data and to create the service. but how this service is used by the insurance company is maybe not the scope of, for example, in FinTech. So if we analyze data from a car to say if you are driver A, B, or C, it's just something agnostic for the pilot. Then inside the insurance company, they will use it. They will have to match this information with their internal data about this user. If this user is allowed to do this or whatever.
And also to complement that, we envision in Infinitech also to provide some data sets into the project from that this is still an ongoing work to understand of which of the pilots are able want to actually provide some information. It will not be the customer data themselves, they might be synthetic data that have been generated by the data set that they have. And in any case, everything will be anonymized.
Okay, so you're not, are you in a position to disclose any insurance organizations availing the service yet? Or it's all still in the pilot stages?
Right now, it's in the pilot stages. I mean, the project has is in the first months, and now we try to identify each pilot how they want to contribute about these data sets.
All right, thank you. Thanks.
Savita, both your questions have been answered, correct?
Yeah, I think the second question is already answered in the Q&A box itself.
Perfect. Okay, Antonis Ramphos, you posed a question: how much big data stack technology relates to cloud edge and computing continuum? Dimostris, you've answered the question. Do you want to elaborate on this a little bit?
Just to say that the key, actually to repeat that the key aspect brought by big data stack in terms of infrastructure management and, you know, in this quite valid question about the cloud edge computing continuum is that we go beyond, so go a step further and say how do the different data aspects affect the resource management, meaning that you can consider deployments on the edge and centralized deployments. But always when you do this type of deployment, you provide and manage your resources. For example, I don't know, you have a scenario of federated learning or something. At the end, the amount of resource you would need or the orchestration of the different containers, you know, any type of management on the infrastructure will relate what data do you get, whether there is any connectivity or, you know, missing connectivity affecting the data streams, what type of analytics you do, you know, how often do you do them. So, you know, all these data related aspects affect the infrastructure management, and this is what we're addressing in big data stack. And, you know, as I replied, it's core to the cloud edge computing continuum, bringing the data aspects angle.
Thank you. Antonis, if you want to reply, if you want to comment on this, you only have to unmute yourself. Oh, I get a message that Antonis has already left. I see another question from Nuria. Nuria, how ready are these industries to adopt this kind of technologies, she asks, even though they already use digital channels for the relationship with customers, their business models remain more or less the same since ages. Who wants to take this question from the panel? Marco, can I invite you?
Regarding Infinitech, we also implement, we focus more on the data specific parts of that. But also we have components about the data regulation mechanism that if this answers to your question, that takes into account that I'm not in the scope to actually explain you how they develop their business models.
Okay, I think that it's a, again, very open question, difficult to answer in general because it's something that will depend on case by case. In the first presentation from Vittorio, he remarked that at least in Infinitech, the insurance or the financial companies are maybe companies that the digital transformation is something that they do maybe not so quick, or it's not so easy for them to do this transition, because they came from accumulation of past technologies or past way of managing data that make this transition complex. It's not like if a new company appears with a new service, maybe for them it's easier to start using new technologies, but when you have a very long period past, is maybe for you more complicated to change. But maybe again, this will depend on the companies or in the strategies. There are some banks or financial companies that maybe they are more they have had during years some technological transition strategies, and for them are easier, and in the same sector for others maybe they did not do any action about that, and now for them it's going to be more complicated. For sure it's not easy, but again it will depend very much on each company and in their past.
Just to complement a bit, sorry.
No, go on, Dimos. I will go later.
I'm changing, my hat from BigDataStack to Infinitech, just to say a bit that there is a key innovation-oriented outcome and target of Infinitech that looks on how, to enable and facilitate this adoption. And this is called, the virtualized digital innovation services we aim at offering. So at the end, raising to the extent possible the abstraction level for enterprises so they can utilize services that are completely abstracted to them in a way that the management, the analytics, the results, the combinations, are all performed by different layers. This is what we call virtualized digital innovation services, and we aim at offering them through a marketplace that could also include such type of services that are turnkey solutions, aiming at addressing exactly what Nuria has been raising, how to foster at the end the adoption.
Yeah. Also, I would like to implement something about what Jose and Dimos said. Usually, big financial institutions, as I said at the beginning, are very conservative because they have to rely in a lot of regulations. They try to innovate, but it is not easy at all. And actually, all the use cases in Infinitech are industry-driven, so are raised from the financial industries and are applications or developments that they try to implement, so that they would like to change in their business models. So all the financial institutions have some departments that implement some innovative solutions. Some banks are more updated, others are less updated. And also there are a lot of fintech companies and high-tech companies that let's say try to fill this gap in providing very innovative solutions in the same concept, just because they are smaller and they do not have to rely on all that bureaucracy that all these financial institutions have. And lastly, regarding the virtualized digital innovation hub, as Dimos said, the objective of this VDIH is exactly to help all the financial institutions in order to drive them to the digital transformation. So exploiting the expertise of the consortium, especially of the fintech and the high-tech companies, providing services and consultant in order to help all these financial institutions to change their business models and adopt these technologies and achieve these solutions. And that's all from my side.
If I can add something from the banking perspective, the question is very interesting, because you're talking about innovation and how we can talk about innovation if the business model stays still. I would differentiate in two aspects. A first discussion is about the innovation of the bank, and the second is the innovation of the banking services. Those are very different issues, because when we talk about the innovation of banks, we have also to wonder if the bank needs to change their business model, and what is the role of the bank inside the social environment. I could tell you about some experiences of banks that probably, especially in some countries like in Italy, I would say, where the economy is still driven by small and medium enterprise, and the banks have a very important role in providing support to those small and medium enterprise. It's important also that the reference, the model continues to adapt to the need of their customer, that probably is not always so innovative. Sometimes you have to support small companies. Also, your customers are sometimes old or less rapid in innovating. So probably, I think it's not so wrong to imagine that the bank would go at 2 different speeds at the same time. There is a part of the bank that has to continue working as it works now, because in the years we get a sort of trust from the customer, from the market, from the ecosystem. And so we have to keep this model of trust also for the components of the ecosystem that are not so fast, are not so innovative. Second, we have to work to a second speed that should be faster, because of course we have to develop the innovation of services, of banking services. It's something that banking are still doing right now, in order to be ready for the change of the ecosystem that is provided, that is arriving. So I don't see so problematic the fact that business models stay at the same as many years, because we also have to keep into consideration that part of the ecosystem that is not so fast, that is not so innovative, and we have to be a sort of pillar for the economy as banks. Second, we have to go to the innovation of services following this new technology and new approaches. It's not only one bank with one speed, but one bank, 2 speeds. That's my opinion. I don't know if there are other questions.
Last brief comment from my side. Also, in order to innovate and use these technologies, the banks are also opening themselves to more threats, for example, regarding cybersecurity. Indeed, there are a lot of regulations such as PSD2 that try to limitate these issues and regulate these issues, because when we talk about a lot of money, a lot of transactions, also these have to be taken into account.
Thank you. Nuria, do you want to comment on this? You can do that by unmuting yourself. This is a possibility. No? Any other questions that we haven't answered yet? Now is the time to ask them. No? Then I would like to thank all speakers for their efforts, for their explanations, their wonderful presentations of today. We will make the recordings and the slides available after the webinar, and you'll be able to look at them afterwards in your own speed. You'll receive a mail updating you on this as well, so you can also, if you have any questions, you can answer the mail, and we'll feed that into the right person that will provide you with the answer. You can also follow us, of course, on social media, as you've already seen at the beginning. So thank you very much. Thank you all to the speakers, and have a very nice day.
Thank you all.
Thank you all.
Thank you all to the participants, and bye-bye.
Thank you. Bye-bye.